So let's talk about Glow. And there are several of these. These are more modern smart contract languages intending to fix the defects in Solidity. And there are other ones. I think there's even more famous ones, but the one I learned about was Glow. So to do this project, you need to use your Linux cloud server, and you will want to copy and paste commands into it. So the way to do that is to put PuTTY on your Windows machine and SSH into your Windows cloud server from the Windows machine. And I can show you how to do that. Now I've got a virtual machine running on my Mac, a local install, so I can just SSH in directly, which lets me do it. But I can help you get this set up in the cloud servers. So the point of Glow, as you will see, is that it is much, much easier to write a contract, and it is much, much more secure. So you execute a few commands to install Glow, and then you've got Glow. Glow help. We'll show you the help message from Glow that shows that it's installed, and it really isn't very much to it. And you can run a local Ethereum testnet. Just like the ones that we used in that remix, the JavaScript ones, this runs a local Ethereum testnet. And it tells you it's running. And creating some wrapper, private Ethereum testnet. And creating a few contracts, and it's done. Okay, so now my machine is running a local Ethereum testnet. Now I can create an identity. In the Glow, this is going to create a person named Alice on the testnet network. And giving me a SQLite error. That's not good. It may be that I've already got an Alice. Let me try making Alice 2. All right. Constraint failed. Irritants 19. Okay. I'm going to use Alice 3. That's right. I've already done it a couple times, and I'm trying to make a new account where one already exists. That's all. So I generate an identity, and it makes them an account. So now I want to also make a Bob account. Let's all make Bob 3. All right. So now I have a couple of accounts in my network, and now I want to fund these accounts from the faucet. So I can do Glow list identities, which will show the identities in the network. And as you can see, I already had Alice and Bob and Alice 2 from the past, so now I've got Alice 3 and Bob 3. These are the new ones I've made. And now I can give them some tokens with Glow Faucet, just the command line version of what you did before. So that's going to be to Alice 3. All right, there goes some transaction. So Alice 3 got 5 PET. PET seems to be the currency of this blockchain. And Bob 3 doesn't like Bob 3. I thought I created Bob 3. Oh, I had Bob 33 by accident. All right. Let me create the Bob 3. All right. Now I've made Bob 3. Now I can load up Bob 3 from the faucet. Okay. There we go. Now, we can perform a transfer from Alice to Bob of 1 PET. And so I've got a transfer from Alice 3, from Alice's database. There's Alice 3 to Bob 3. There we go. The transaction is succeeding. And afterwards, Alice has 4 and Bob has 6, because I moved one from there, and you see there's a little bit of money subtracted for the gas. Now, we're going to have a simple situation. And here's the game. Alice is going to pay Bob as a notary to sign a document. And so the point is she has to pay Bob money, and Bob has to return something of value to her, and she has to agree that it has value. That's the contract. So here is how you do it. I make, all right, so this creates a message called document.test. This creates a digest of document.test. And this starts an interaction from Alice 3. All right. And now I can use a built-in contract. And the one we're going to use is by SIG. This is the one they give. It's one of their demonstrations. So that's going to be 1. And now choose your identity. And I'm Alice 3, so that's number 3. And I am the buyer. And I'm going to send it to Bob 3, which is 5. And 1 for pet, the type of coin I'm sending. And then at the enter digest, right, then I have to put in the digest which I calculated earlier, which was this. Okay. And now the price will be 1. And this is an important thing about the Glow system. When you do a transaction, it doesn't just wait to be mined indefinitely. It waits for a certain period of time, and after that, it's automatically reverted. So everything has a lifetime, and you give it something. Current block number is 308, and what I said is add 100 to it. That'll give you a few minutes. So 308, I'll make 408 here. So if it reaches block 408, and this transaction is not complete, it will automatically revert. So now it has made this offer from Alice 3 to Bob 3 that if you sign this document, I will pay you 1 pet. And here's the handshake agreement that has to be sent over. So I need to have another terminal window. And let me make that and SSH to my Debian machine. So that is, there's the address. So SSH Debian at 172.16. Okay. Okay. So on my second machine, I paste the first command, Glow Start Interaction Agreement. Okay, this is the command for the other person to join. I have to copy this whole command, and I have to add something to the end of it because otherwise it's going to try to use some real public blockchain. I have to add this stuff to the end to tell it to use my local simulated blockchain. So this is Bob3.5 agreeing to, and he is the seller. Okay, and now I need to paste in the handshake, which is this stuff. All right. And now both windows show an interaction finished. Yep. And the handshake. So this now has performed this activity manually. It has now done this exchange for a signature. Okay, and now we're going to do this in Glow. So here's the situation. You pay for a signature on this digest with this price. Can you please sign it? Bob is going to create the signature, then publish the signature so that people can verify that it is correct. And once Alice agrees that the signature is correct, then Bob withdraws the deposit. So the blockchain holds the money as like a escrow agent. The money goes here, it sits here until Bob does the work and Alice agrees to it. And after that happens, then the money goes here. That's how it works. And this is the entire contract. Remember how these other contracts had dozens or hundreds of lines and mistakes. So here's the whole story. This is the interaction between buyer and seller. They both have to agree to participate in this interaction. Then 3, you're going to have a digest and a price. That's the signature. And so the buyer deposits the money. They put in the price. They deposit this onto the blockchain. Then Bob computes the signature, and the seller and the other person has to verify it. It creates a verifiable thing and then publishes it so the other person can see it. And then the other person has to verify it. And after that, it then goes to withdraw here. So the point of this is, if the buyer never pays, then it stops at line 4 because it doesn't do this deposit, so nothing later ever happens. Okay? If the buyer pays but the seller never signs, then the buyer puts the money in escrow, but the seller never signs it, so this never happens, so it will just time out and return the transaction to the person who put up the money. And if the seller sends an invalid signature, then this will not get verified, so it will never proceed to let the seller have the money, and again, after enough blocks have gone by, it will cancel, and that'll be the end of it. So that's the game here, and that's the contract we were just using manually, and you can make your own. So I've already made this directory. I'm just going to make a new one. I'm going to call this one sig3.glow. Okay. And give it this code. All right. And I can see my application in the list of available applications now. And there it is, my sig3.glow that I just added. All right. And so if I prepare this, there's going to be an error in that one. And then there's an error in that app to be fixed. So anyway, there's a few things here just to give you a little bit of playing with this language. The point is, code is much shorter in this language, and it's easier to write secure code. That's the idea. So that's what I wanted to show you about Glow.